Okay, I'm going to talk through this question so that you can get some help if you're struggling with maybe how to think about these questions. This one looks very intimidating because there's a lot going on here, but I want to show you how simple these can be if you do a couple things. So the first recommendation I'm going to make is always go ahead and find your arcs first. So for instance, we know the arcs add up to 360 degrees. Let me go ahead and put in the numbers for what we know here, because we've got 100 degrees is marked on the picture, I think. Yep, that one's there. CE is 30 degrees, so that's right here. 30 degrees. And then the last thing that I know is EF is 25 degrees. And if I put those on there, let's try to make it legible, then I think that's going to be helpful because I can go back to those and use them as much as I want. Now, my next suggestion for you is find the arcs that you don't know. So we know they all add up to 360. The other fact that I can tell you that's like kind of hidden, it's not that you don't know it, it's just that it tends to get lost in all the lines in the picture, is if you have a diameter, so in this case we're passing through, and they did tell you that this is circle O, so I know O is the exact center of the circle. That means I have 180 degrees for each semicircle. So that's going to allow me to find this arc here is going to be 80 degrees, giving me 180 from A to F over here. And then likewise, I've got this arc here is going to be 180 minus 30 minus 25, or add those up first. That gives you 55, subtract from 180, and that's how I'm getting 125 degrees there. Okay, so now we're ready to find our angles. So that's my first suggestion, is find your arcs. So to find your angles, you need to talk yourself through these. If you're struggling with these, you need to ask yourself these two questions. And if you were in class with me, you would hear me say this over and over and over. I would sound like a broken record. What kind of an angle do you have? And I'm not talking about acute, obtuse, or right. I'm talking about what kind of an angle in your circle. So we have 4 options, and let's go ahead and just remind ourselves of those. We should have these in our head. Central, inscribed, interior, and exterior. And if you don't have those down, you're going to get really confused by this. If you know what those are, then it's just a matter of asking yourself every time and having yourself holding yourself accountable to using the correct relationship. So let's just go in order and see what we can make of this. So angle 1 is the first one I'm going to look for, and angle 1 I'm noticing is a central angle. Why did I say that? Because the vertex is the center of the circle. It's right there. It's O. Therefore, central angle is equal to your arc. So central angle, angle 1 is 80 degrees. Done. Equal to the arc. If I extend this out, that's why I'm taking this 80-degree arc right here. Angle 2 is also a central angle. There's a couple ways I can get this. I can go out to its arc, which would be over here, the 100-degree arc, and I could use that. The other thing I could do is, you might be noticing that angle 1 and angle 2 are supplementary, and all the way back from chapter 1, those are a linear pair, and absolutely those would be a supplementary angle pair. Okay, moving on to angle 3. So angle 3, vertex is on the circle. So this one, angle 3, if I'm tracing that, vertex is point A, if I name that. CAF would be a name for that angle, and A is on the circle. So if its vertex is on the circle, that's an inscribed angle, and an inscribed angle is equal to 1/2 my arc. Oops, didn't want to do that. Okay, you're going to have to just kind of read my squeezed in writing there. So if it's 1/2 the arc, well, then I got to find the arc. Well, the arc is this entire thing, and that is 55 degrees. Don't get tricked here with just using the 30 or the 25. 55 divided by 2, you absolutely can have a decimal for these. Angle 3 is 27.5 degrees. And I do like writing these on the picture. Sometimes it's hard to like squeeze them in there, but it is helpful because, for instance, 7, 8, and 3, those 3 angles are going to add up to 180. So that's a good double check at the end. You can also use angles in a triangle, that sort of thing, to help you out here. Okay, we'll keep going in order. So angle 4, if I'm using angle 4 is what kind of an angle? Talking myself through this. Yeah, that's an interior angle, not central. Vertex is not the center of the circle. Vertex is right here. It's just somewhere inside the circle. So therefore, I've got to use my interior angle. So this is a little tricky. This is one of our newer ones. It's not equal to the arc, so it's not 80 degrees. I see this 80-degree arc, but it's not equal to that. It's also not half of that. So interior angle is, my relationship is Arc plus arc divided by 2. Add up the arcs divided by 2. So where are the two arcs coming from? Well, one of them is this one right inside of this angle, the 80-degree arc. The second one is, now we got to be a little creative here. We got to recognize that these two angles, angle 4 and, just for sake of discussion, let's call this angle 9 here, because I think I stopped at 8. 4 and 9 are congruent. Those are vertical angles. So I've got to follow and find the arc inside angle 9, and I'm basically averaging them. This is like an average, right? I'm averaging the two arcs. So I'm going from here to here, and then, so if you can follow my red, I know I've got a lot going on in this picture, but my two red arcs are 80 degrees. And 125 plus 30, so that's actually 155 is the other arc there. And if I do that, I've got 155 plus 80 divided by 2, and that's giving me 117.5 degrees for angle 4. Let's see if I can, whoops, yep, really doesn't want to let me move stuff. Perhaps. No, this thing really just doesn't like me. Okay, we'll work with it. So angle 5 is the next one. And angle 5 should be another interior angle. So you've got two options here for angle 5. You can just go with the supplement of angle 4, 180 minus 117.5. Or kind of a good double check would be you can go with, let's see what color I can use here. You can go with 5 and this angle over here. Then I'm highlighting in blue. Those two are going to be the same as each other, and that's another interior angle. So you could go with this arc plus this arc here, plus this arc here, and divide by 2, average those. And if I were to do that, I'm getting 100 for this arc here, plus this was my 25-degree arc. Divide that by 2, 125 divided by 2 is in fact 62.5 degrees. And there's the supplementary relationship that I was just talking about. Okay, moving on. Now I'm on to angle 6. So angle 6 is the only angle in this problem that is an exterior angle. So notice that if you're looking at angle 6, the vertex is outside the circle. Not hard to recognize. Let's go with this. And if I follow out, so follow my yellow markings that I'm making right now, and I'm just tracing that angle. Vertex again, point D, outside of my circle somewhere. So exterior angle, that's the only one that I haven't put on here. Exterior angle is, whoops, arc minus arc. So it's very similar to my interior. Divided by 2. So that's my exterior angle. Let's see if it'll let me erase somewhere here. Okay, make myself a little bit of room here. So some of this is apparently not erasing. Sorry, I'm not fantastic with iPads. So, yep, okay, yeah, we'll just go with it. So for my exterior angle, that's angle 6 that I'm looking for. Angle 6 is going to be arc minus arc. I'm finding the two arcs inside my angle. So you're looking inside that angle that I highlighted in yellow, and you're noticing that the arcs inside of it would be this arc and then this arc. Like literally cover up the rest of your circle and just look at what would be cut. If you cut out that angle, what would be left? So we're always going to do big arc minus little arc. Big arc in this case, it's always the furthest one away, just to avoid getting a negative number, because negative angles don't make a whole lot of sense to our brain. 100 minus 30 degrees divided by 2, that's 70 divided by 2, and that's giving me 35 degrees for angle 6. Okay, we got 2 left. 7 and 8, these are actually old angles, as in this was last week's stuff before we talked about interior and exterior, but these are still giving us some trouble. Inscribed angles, because my vertex is on the circle, but here's the trick. If I highlight angle 6, and then if I highlight angle 8 here, vertex is right there, point A I think it was before I drew all over it. So vertex is definitely on the circle. The problem is that it's just a little bit different than angle 3. Go back to 3, and 3 was this nice one where you've got the two chords or lines that are going through my circle, vertex here, and we just go across. We can nicely find that arc inside if we wanted to find angle 3, which was one of the first things we did. I can still do that. It's just that the arc goes all the way inside the angle. So if I'm looking at angle 7 here, the arc starts here inside of it. Think about cutting off that half of the circle. Think about covering up that top half. This arc goes all the way to the vertex point. So that arc is actually the entire semicircle, since we had a diameter here, which is 180 degrees. Therefore, inscribed angle, yep, that's right, it's 1/2 my arc. Therefore, it's going to be 90 degrees, 1/2 of 180. So you might be noticing something here, that anytime, and I'm just going to pause right here and let you think about this, anytime that you have a diameter, or we could say just a radius, in fact, if it's not extended through your circle, and you have a tangent line, that they're always going to be perpendicular to each other. Think about it. It's always going to be half of a semicircle that's created there. So that's just kind of a fun fact, and maybe that'll help you out there. Last one there, angle 8. I don't want to forget about it. So hopefully you can see that there's a 125 degree arc is the arc inside of that angle. The rest of it's not part of it. If I'm cutting out that angle, the rest of it is gone. 125 divided by 2, because an inscribed angle is half my arc. So 125 divided by 2, 62.5 degrees is what I'm getting for angle 8. Like I said, you could do a quick double check here. 8 plus 3 plus 7, those 3 angles added up should be giving you 180 degrees. Quick clarification point, angle 8 and angle 7 were not meant to be marked as congruent, but I can see that that might have been confusing if you looked at it and thought, because we have used arc marks to indicate that. So that was more to indicate that your angle was going all the way to the tangent line, and not, sometimes people think the angle is created by the segment and then the curve, and that's not actually the angle. So hopefully that helps. If you didn't have this in a nice organized place in your notes, I didn't write it the most organized here, but I would make sure that all of this information is stuff that you've got down for relationships for 4 different types of angles in our circles.